Hello, welcome to video number 78. This is about combinations, also known as N choose R. This is an important part of the binomial model. All right, let's get going. Here, I want to consider an example. This is a typical problem of combinations. Suppose there are 23 AP statistics students and 7 free movie tickets. How many different groups could go? If you start thinking about the different possibilities, there's actually a very large number. And we're going to learn how to calculate this. Usually we're going to use our calculator to do something like this. So let me get my pen going here. Let's do it. So one way to say this is 23. We have 23 people. Choose 7. The way to write this mathematically almost looks like a chemistry formula. One way to write it, and probably the way we're going to write it, is with a big C for choose. We put the 23, the total number of people or things we have, on the left, and the number of things we're choosing on the right. 23 choose 7. So that's assuming that order doesn't matter. It doesn't matter if Bob is picked before Freddie. All that matters are just the 7 different groups of people we find. So like I said, it looks like a carbon formula for carbon or something, but it's 23 choose 7. Sometimes you're going to see this written like this, 23 and 7 inside parentheses. So that means 23 choose 7. Okay, now there's a way to do this on your calculator, and that's what we're going to use most of the time. If you press the math key on your calculator, then go over to probability, the third option you see here is NCR, N choose R. You have N things. You want to know the number of ways you can choose R of them. All right, now, unfortunately, if you just did that on your calculator, you have to back up a little bit. When you're actually using this command, you have to enter N first. So you have to enter 23, then go to Math, Probability, and choose NCR, then enter the number of objects we're choosing. And we see that 23 choose 7 is huge. There are actually 245,157 ways we could pick 7 students out of 23 to go to the movies. If you start kind of writing out the possibilities, you'd become a believer. There are a lot of ways of doing it. Okay, so this kind of comes from probability or counting problems. All right, so we want to do some examples here of just computing this number. So this first one says 5 choose 3. We have 5 objects. We want to know how many ways we can choose 3 of them. Well, I'm going to use my virtual calculator here to show you how to do this. So I'm going to turn this on. I'm going to press 5, that's N. Then I have to go to Math, go over to Probability, and there it is, the third one. So in 5, NCR 3, 5 choose 3. And it turns out that would be 10. If I have 5 things and I choose 3 of them, there are 10 different ways we can do it. So let me write that in here. So this would be 10. Okay, 14 choose 2. Here we go. Pull up my cool little calculator again. And I'm going to enter 14. Then I go Math, Probability, NCR, and I'm going to choose 2. So suppose we have 14 people and 2 of them get to do something. How many groups of 2 can we pick? Well, here it is. You can get to pick 91 different groups. So there's 91 different possibilities for that. All right, here are a couple of word problems. How many different committees of 3 members can be formed from a group of 8 people? So 8 is the total we have. So what we need is 8 choose 3. And of course, the way we would write that is 8, a big C, capital C, and 3. 8 choose 3. All right, let's do it. So I'm going to pull up my calculator, clear that out. 8, Math, go over to Probability, NCR, 3. 8 choose 3 is 56. So you could form 56 different committees of people if you pick 3 from 8, 56. Okay, here's another example. Suppose you're required to read any 4 books from a list of 15. How many different selections are possible? So how many different ways can you pick the 4 books? Well, that'd be 15. Choose 4. Again, order doesn't matter. If order matters, if it makes a difference what order you pick them, that's actually something else. That's NPR. And you see that command on the calculator, but this is in choose R. Order doesn't matter. So here we go. We got 15. Go to math, probability. See, and PR is right there, number 2. That's if order makes a difference, but we don't want that. We want 3. And we're choosing 4. You can choose your books 1,365 different ways. So this would be 1,365. Easy. Now, we don't need to know too much about this. You just need to know what nChooseR is and how to do it on the calculator. All right, let's try 2 more examples. Pizza Mind offers 10 different toppings for its pizzas. Suppose you order a pizza with 3 toppings. How many different combinations are possible? This is actually a very practical math formula we're using. So we're interested in 10, choose 3. Okay, I don't know what that is, so I'll go back here and figure that out. I'm going to reuse this command. I'll try to use it. I guess I can't. I'm going to try to reuse that command, but I can't. So 10, math, go over to probability, NCR, 3. That's 120 different combinations of toppings. So this is the number of groups of 3 you could pick out of 10 items. All right, last example. 2 students from Sky High School will be chosen for a TV interview. So I'm going to choose 2 out of 900. So this is going to be 900, choose 2. Well, as you can imagine, out of 900 people, there are a lot of ways you could pick 2 of them. But let's see what it is. Okay, so 900, math, probability, NCR 2. Okay, 404,550. In other words, like we said, a lot of different ways. Okay, let's see what's next. That's the basic idea. All right, well, I want to really quickly explain how this relates to the binomial model. We're kind of in the middle of learning about that. And NCR is a important part of it. Suppose you're dealt 10 cards with replacement. What is the probability that 4 of the cards are face cards? This is an example of a binomial model because we're dealt 10 cards. We don't keep going until we get a success like the geometric model. We're dealt 10 cards and we want to know how many successes we'll have. Well, this could happen in a lot of different ways. Maybe the first 4 cards are face cards, and then the other ones are not. That'd be 6 cards that are not. Or maybe the first card is a face card, the second one is, the next 2 are not, the next 2 are face cards, and the rest of them are not, etc. There are a lot of different ways this can happen. We got to figure out how many different ways it could happen. So the number of ways this could happen is 10, choose 4. We're pretty much picking the spots the 4 face cards are going. Okay, so these are different events. Getting the first 4 cards face cards is different than 2 face cards, 2 not face cards, and 2 face cards, etc. We have to count for all the possibilities. So how many different ways can this happen? 10, choose 4. Okay, so I'm going to figure out what that is. So 10, and we're going to go math, probability, 3, choose 4. 210 ways. Okay, now there are 210 different ways and they all have the same probability. They all involve 4 face cards and 6 cards that are not. So the probability would be the number of ways it could happen, 210, times the probability of each way, 4 face cards. Well, 3 out of 13 cards are face cards. So I'm going to raise that to the 4th power because I have 4 face cards. And that means 10 out of 13 are not face cards. I'm going to raise that to the 6th. So this right here is the probability of any one of these happening. There are 210 ways it can happen. So I got to multiply the number of ways it can happen times the probability of each. And that's probably of 4 face cards. So give me one moment. I want to know what this is. I'll do it twice here. So after computing this, I get there's a 12.3% chance that if I'm dealt 10 cards with replacement, that we'll get 4 face cards. It's important that it's with replacement because each trial has to be identical. Okay, so I want to show you very quickly, there is a formula for this. In case you're stuck on an island someplace and you're trying to figure this out without a calculator, there is a formula. This is what your calculator is doing. So to calculate 8 choose 5, you put n. This is n and this is called r. You put n factorial in the numerator, and in the denominator you do r factorial, that's this part right here, times the difference of them, the factorial of that. The difference of them is 3 factorial. Now, 8 factorial is what you get when you do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 5 factorial is what you get when you do 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Now, you might be saying, Mr. Miller, that's totally fine. I'm okay using my calculator, and I'm totally cool with that. But let me just figure out what some of this would be. So, factorial is in the probability menu also. So 8 factorial is 40,320. Let me see what 5 factorial is. 5 factorial is 120. And we have to divide by the product of 120 and 3 factorial. 3 factorial is easy, that's 6. Okay, so let me try this. 40,320 divided by parentheses 6 times 120, I get 56. Wow. So that's pretty complicated. It's a lot easier to use just the calculator, the button. So here, 10 choose 4 would be 10 factorial divided by 4 factorial times the difference, 6 factorial. Okay, now, you don't really have to worry about this too much. Just want to let you know there is a formula for this. It's based on factorials. Okay, it is time for your journal assignment. So I totally want you to use NCR in the calculator under the probability menu. So this will be very quick. You have 6 problems here. Go ahead and solve them using your calculator and write your solutions in your journal. See you next time.